Hello Lightning Leaders, and welcome back to another math video. Today we're going to be talking about something that is probably the hardest thing in our fractions unit, and that is multiplying fractions by whole numbers and using the associative property to manipulate some numbers, which is just going to get super confusing and complicated, and it's going to be nasty, but we're going to get through it together. So throughout this explanation, I'm going to be working on one multiplication equation to work through, manipulate, and talk about while we do our work here. Now, this is something I want you to keep in mind while we're talking about this. I want you to think about 4 times 3 centimeters equals 12 centimeters. I want you to keep this in mind. We had 3 centimeters. We made 4 copies of it. So now we have 12 centimeters. This should look familiar. We did this stuff back in 3rd grade. We did it again in 4th grade. Notice how the unit came along. Because there was a unit here, it was also a part of our answer. This is going to become super important as we get into the fraction part of this lesson. Now, I'm going to rewrite this as a fraction, or as a fraction multiplication sentence, but in unit form. 4 times 3 fifths equals 12 fifths. Look at this. It's the same exact number sentence. 4 times 3 equals 12. 4 times 3 equals 12. All we did was change our unit. Up here, we were talking about centimeters. Down here, we were talking about fifths. So it's the same process. It's just confusing because we are talking about fractions. And when we start talking about fractions and these small pieces, our brains just start to turn to mush, and it gets all jumbled up. So we're going to try to go super slow. Keep this in mind, because this is going to help you as we go through this lesson. Now, look what we did here. Instead of doing 4 times 3 fifths, really what we did first was we just did 4 times 3. Look at that. We really just did 4 times 3. It equals 12. And our unit was fifths, and it just came along. If we were to write this as a tape diagram, right? If we were to write this as a tape diagram, we would need bundles of fifths, right? Let's say each of these is 1/5, so the whole thing is 3 fifths. But I don't have 4 of them, so I would need another copy. But now I only have 6, so I need another copy. Let's see, I only have 3 copies of it. I need 4 copies, so I need 1 more. So now I have 4 sets of 3 fifths. That's exactly what we did here. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And we did it 4 times. I'm going to grab a different color here so you can see this. We did it 4 times. We did it 4 times. And if I were to add these all up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 fifths. So this is a visual representation of what this is. This might sound familiar from back when we were doing our arrays and our rows and columns, where we needed to add in rows or add in columns, making multiple copies of it to get our multiplication. Because what multiplication is we are taking something and making a number of copies until we've gotten to the number we need to get to, which is different from addition, where we're combining things together. Multiplication, we're making bigger and bigger and bigger and bigger and bigger numbers. So this is how this question could have been shown with the tape diagram and unit form. Notice again how we stuck with the 4 times 3 equals 12. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. 3 times 4 equals 12. What I'm going to do here is I'm going to leave this 4 times 3 up here, but we're going to look at this in a little bit different way here. Now I'm going to write the multiplication equation in standard form. 4 times 3/5 equals 12/5. Look at what we did here. Are you seeing that 4 times 3? 4 times 3 is 12. Our unit was 5. Nothing changed here. I'll write this back out. 4 times 3/5 equals 12/5. Same equation written 2 different ways. But once we start writing it like this is where things get tricky, because I'm sure a lot of you wanted to write this answer as 12/20. But that is not what we do when we're multiplying a whole number by a fraction. Look what happened here. 4 times 3 equals 12. Fifths was our unit. 4 times 3 pieces equals 12 pieces, and our unit was fifths. What we ended up doing was something like this. 4 times 3 times 1/5. And we know that when we see parentheses, this is what we need to do first. 12 times 1/5. And then, thinking back to when we first started doing multiplication, we used repeated addition, which means we would have something that looks like this. 1/5 plus 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 1/5. That's a lot. That's a lot to write out. But if we count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12/5. 12/5. So what we're doing here is we're taking the whole number, multiplying it by the numerator, and getting our answer. Here it is shown a different way, and here it is shown yet another way. This is the math that we're doing. This is the math we're doing in our head. This is where we're leading. So let's give this another try with a different example here. Let's try 5 times 3/4. And I'm going to write it out in unit form and in standard form. Let's take a look at this. 5 times 3/4. Now we're at the point where I'm not going to ask you to turn these into mixed numbers. We're going to leave our answers as improper fractions right now. Let's look here. 5 times 3/4. Our unit is fourths, so we're not doing anything with it. It's going to come along and be in our answer. So I'm going to write my fourths over here, and since it's coming along to be in my answer, there's my unit written 2 different ways, the same thing, and now I'm ready to solve. 5 times 3, 5, 10, 15. So up here, this way is showing me 5 times 3/4 equals 15/4. Let's see if it works down here. 5 times 3, 5, 10, 15. 15/4. We got the same answer. What we ended up doing was something like this. 5 times 3 over 4. Right? Here's why this is working. if you watched my other videos, you already know this. You can turn any whole number into a fraction by putting it over the number 1. I can rewrite this number sentence like this. And when you're multiplying fractions like this, you just go across. You keep that line separating your top and bottom numbers. So let's see. 5 times 3 is 15. 1 times 4 is 4. Oh, we got the same answer again. So this may seem complicated at first, but if you think about the strategies we've been doing, if you think about how we've been moving fractions around, think about the size, the unit, everything we've been talking about, it starts to come together. Let's try another one. I wrote down one more example here. Eight times 2/3. Let's try this one. Now, we can do a few different things here. We can write 2/3 8 times and add it up, right? That works because this is repeated addition. 2/3, 2/3, 2/3, 2/3. It's only 4 of them. 5, 6, 7, 8. I can do that, but that's a lot of work. That's a lot of work there. But we do know that multiplication is just a shortcut for repeated addition. Another thing we can do here is we can rewrite it like this. 8 times 2 times 1/3. Because our unit is thirds, we are trying to figure out how many thirds we have. So technically, I can rewrite this like this as well. 8 times 2/3. Just like this. We're going to get the same answer. Or, fix my equal sign. Oh man, that equal sign is just not wanting to cooperate. There we go. Or we can write it the other way I showed you, where we can make that 8 into a fraction by putting it over 1. And now we have a few different strategies here to solve. We have 3 different strategies to solve this same answer here. Let's see what we get. 2, 4, 6, 8, 10, 12, 14. All right, our repeated addition ended up being 16/3. Let's see if we get the same responses or the same answers in our other methods. 8 times 2 is 16, and our unit came along for the ride. Let's try it again. 8 times 2 is 16. 1 times 3 is 3. Remember, when we're multiplying fractions, we go across. We keep that line separating them, and the top and bottom don't talk to each other. We just go across horizontally. We could have also written this out in unit form, 8 times 2/3. And again, it would have just been 8 times 2, which would have been 16/3. We got 16/3 4 different ways. 4 different ways. The reason I show you all of these different ways is because one strategy may work for someone, but it may not work for someone else. So I want to give you all of these examples so that you can pick one that clicks for you, that makes sense for you, so that you can do this work. We're not trying to get everyone to do the same thing because that's not fair. Some people may not understand one of these strategies. So I'm showing you all of these strategies in the hopes that one of them works for you. Now, when we do our number talk, sometimes we talk about efficiency, which means which of these strategies is the quickest. Now, doing this repeated addition strategy, that's not very efficient. Look at how much we had to write out here. But it's a strategy to start with, to build up to until you can get up to these higher level strategies. I would start with repeated addition, and until you feel comfortable with that, then I would move to the unit form one. because you get to see how the unit comes through. Because adding this over 3 sometimes makes things confusing because it looks different. The visual sometimes tricks your brain. So by keeping your unit as a word, you can see the numbers that you're working with. Then, once you start to understand this a little better, these ones will start to click. Personally, my favorite is this one. This is the one I like to use because this is something you're going to see once you get into the higher grades and you're going to start doing things like 3/4 times 5/6 or stuff like that. But whatever strategy works for you is the one I want you to use. So I hope that going through these strategies helped clear up some of the confusions you were having with the Zern lessons surrounding the multiplying of fractions. Believe it or not, the multiplying fractions is actually the last topic in Module 5. And once you're completed with that, once you've reached, I think it's lesson 40 in Zern, you move on to Module 6, which is finally our decimals unit. So those of you that have been trucking along, you've been moving through the fractions unit. Those of you that are a little farther behind, that's okay. You're working at your own pace. But a good number of you are going to be getting to decimals by the end of the year. So that's super cool. I hope this video helped. As always, send me a message on Google Classroom if you're struggling with something. I've been reaching out to a few of you if I've been seeing something. But as always, let me know, let Ms. Lauk know, let Ms. Bartlett know, and we are more than happy to help you guys. With that said, that's the end of this video, and I will see you guys next time.